Hi everyone. Firstly, very good morning. And can you hear me? And you can see my
Yeah,
screen, right?
yeah. Good morning, Naveen.
Morning. So I see a few new faces here today. Welcome aboard. Just let us give 2 more minutes. I see few people are again asking for joining links, so we'll give them 2 minutes to join.
Yeah.
Okay, now I think we can start the session. So, since some of you are joining for the first time, let me introduce myself. This is Naveen, and I have close to 9 years of experience, and I'm currently working as a AI specialist. I'm a part-time generative AI trainer. So I have been graduated from NIT Trichy in 2016, and have been working as a software engineer, particularly on this machine learning and in this generative AI. I have been in uh, you know around 3 years of experience. I mean, I have been in from the starting of generative AI. Right, earlier I was working as a machine learning AI specialist, particularly the designation being the AI specialist. Right, and this is all about myself. And as some of you again for the first time, I'll have to quickly recap what we have covered in yesterday's session so that you are all on the same page. So hope you can see my notepad over here, and I'll just be a brief brush up, and then we'll smoothly move on to today's topic. So let us get started. And yesterday's session, what we have seen is that we have seen the differences between these subfields of artificial intelligence. So that's the reason I kept the points already written over here instead of writing once again, okay, which consumes some time. Because I want to keep this session as much informative, because we'll be introducing you to deep learning. So I need a couple of minutes or some time to um, close it or conclude this session perfectly. Okay, so let's go through the definitions of artificial intelligence and machine learning and all. So as you already know, artificial intelligence is any technique that enables machines to mimic human intelligence, okay, or perform tasks in a smart way, right? So decision making, language understanding, and we have seen the other capabilities like text generation, image generation, right? So these are all the capabilities of any computer based artificial intelligence system, right? So that is the difference definition of artificial intelligence. And then we will move to, so what is machine learning? Machine learning is a subfield of artificial intelligence. So what it will do is that it allows machines to learn from data, identify the patterns. So whatever data we are going to provide to that particular machine, it finds or identifies the patterns in the data and make decisions with minimal human intervention. All right, so instead of hard coding all the rules, the computer learns patterns from the data itself. Okay, so if you ask me, the examples of machine learning, yesterday we were seeing, right, email spam detection. Oh, let me write it over here itself. So email spam detection, so I'll just keep it as email. And Netflix or Amazon recommendation of movies or products, so I'll keep it as recommendations. And then credit card fraud detections, fraud. Okay, so etc. Even Google Maps, or you can take the Gmail, this arranging of emails based on the content. So these are all kind of machine learning algorithms. Okay, and then deep learning, so which we are going to have a thorough discussion today. So deep learning is a subfield of artificial intelligence again, and deep learning is can also be a subfield of machine learning here. And the techniques we use right inside the deep learning, so which are nothing but your multi-layered neural networks or artificial neural networks or a type of ML based algorithms. Okay, so don't get confused here on different definitions, but for now you can remember that as deep learning uses multi-layered neural networks that discover complex patterns automatically. Okay, and then we have seen the here also we can say few of the applications or uses of deep learning, right, that we'll cover in detail, right. um, and then so examples here being I'll tell you in the next couple of minutes. And then generative AI, this particular field, which is a buzzword from couple of months, right, from 2 years, something like that. Everybody is talking about generative AI. So by the name itself, generative, it means that it will focus on creating the new content. So whether it may be text, images, audio, video, code, or whatever it may be. Now generative AI is being used not only in these four places, but in most of the places, as we have seen yesterday. Since few people did not attend yesterday, so I request you people to go through the first video. Okay, so this is what we have discussed yesterday. So text, images, audio, and video are not only the capabilities of generative AI. However, so we are using generative AI in most of the fields today. All right, so this is all about it. And now yesterday also we have discussed the roadmap for learning generative AI or become a generative AI engineer, right. So firstly we will have to start with Python, right. So we'll go in detail in our course curriculum as well. I have shown yesterday itself the course curriculum, you can go through that. So we will have a thorough sessions on in Python deep. It's not about the fundamentals only, we will have a deep coverage, thorough coverage. And then we'll move to maths and statistics, where you will be learning all these things. And machine learning essentials, yes, you will be supervised learning, unsupervised learning, model evaluation, and training and tuning. Those things you are going to learn as part of your machine learning essentials. And then from here we are going to have a thorough discussion on generative AI. Okay, so deep learning foundations is what we are going to see. Yesterday I have shown you sorry yesterday I have shown you the previous class details as well, right. We are going to have a thorough coverage on each of the topics I have mentioned, though I keep is it as simple as possible. But of course the concept requires a deep understanding, like I'm showing over here. Okay, so these are all the deep classes, and we are going through. And Python and maths is over here, Python is here, and maths and statistics will be explained detailedly for your clearly. And then machine learning also same, so you are going to have some more content for your batch, because the types of questions being asked in the interviews, I see they are asking a little bit on this machine learning as well. And so we would like to cover 100% of this whatever people are aspiring for, or I mean at least in the interviews. So we'll be covering all that starting from your batch. So that part we have seen. So deep learning foundations, we'll be covering that, and natural language processing, we will see the traditional NLP, deep learning NLP, and the modern NLP. So those kind of things we are going to see here. So I kept it as simple as possible. And generative AI basics, so we'll be starting with the transformers as soon as we complete sequence to sequence modeling here. After this NLP, so there will be one more topic. Okay, so after that you will get some very good understanding on that decoder and encoder architecture and all. So after that we'll be covering this generative AI basics, so where we'll be starting on transformers, where you will see the encoder and decoder names once again. So it will be like a flow, it will be like a smooth flow in between the topics. Okay, so we won't be rushing up. So we don't want to take the classes and complete the classes as soon as possible. That's not the thing. We will go in a manner where even a newcomer or a fresher who doesn't have a prior knowledge can understand the concept. So as you can see, the number of contents or number of hours we are teaching for this. And of course all this in a 3 months schedule only. Okay, so I know some of you require this syllabus to be completed as soon as possible, and that doesn't mean we'll have to cover up all the topics as fast as possible, right? No, so it should not work that way. We will cover everything 100%, and within 3 months we'll try to complete all the classes. Okay, so why I'm maintaining this PPTs and all is it saves a lot of time, and of course there will be some complex topics where you might take some amount of time for understanding that. So those topics, you can find it very easily in almost all of the sessions we have. I mean, in almost all of the topics we have, even the large language models or sequence to sequence models. So we have kept a number of simulations here, so just to make you understand the concept very easily. Okay, so what actually happens and the differences and all. So those kind of things we have kept. And I'm searching for one thing, maybe.
Naveen, one question. So
Yes,
do you
please.
also share these resources for us in case we want to go through later after the sessions?
Resources in the sense PPT slides you are asking?
Yeah, this slide looks whatever you are showing in this
Yeah,
presentation, right?
yeah.
So,
So
so you,
whatever,
mm,
yes, I understood your question. So basically, so the question here is being, so whatever the slides I'm showing you right now, so
mhm.
am I going to share these slides to you or not? Okay, to the others. Um, so what I'll be doing is that I'll be putting those slides here along with the matter that is required. Okay, so this is the notes
Mhm.
I'm going to share you. Okay, whatever the slide
Oh,
content
okay.
and all we have. So the as
Mhm.
while I share the notes to you, I'll be putting over all those important slides like this, and I'll be sharing that notes to you. Okay,
Oh, okay. So the PDF you'll be sharing, but so I see that there was some .ai file that you were showing, right?
so
This one, this.
no, sorry, so these things I cannot share, right? So
Oh,
these
okay.
are just for your understanding. Okay, so we'll have a thorough understanding on how things will work inside the class. Okay, so it will be part of your video, but I won't be providing these slides. Okay, whatever the important slides we have, so you
Mhm.
have seen the notes, right? Those are all important slides. Okay, so whatever it is going to make all these animations and all I could not provide, right? So these animations and all I cannot provide to you. I mean, those won't play in PDFs or whatever the format. That is the reason I usually play it in a separate presentation maker. All right.
Mhm. Okay. And the videos. So, oh, you were showing some videos earlier, right? For class date
Mm,
with everything. So in your Google Drive or somewhere. So that will be
Yes,
shared
yes.
after each session.
Yes, yes, yes. That I'll be sharing the videos you are asking, right? Whatever the videos you can see that will be shared to you. So that's that. Those are nothing but the recorded sessions.
Oh, the recorded sessions. Okay. Mhm. Okay. Yeah, thank you.
Yeah, the recorded sessions for the previous batch.
Yes, those are the recorded sessions of the current batch which is going on.
Yeah.
Yeah. Okay. So, so this is what we have covered: generative AI basics and generative AI advanced, and totally we'll be covering at least some 20 projects, mini projects. I mean, for all these things. So, in deep learning itself, you will find some 5 projects and five like that. So, it will be like 20 projects, 20 mini projects by the end of the course, and along with that, you will find 2 capstone projects. Okay, so which gives you very good understanding on how things go inside, I mean the real time. All right, and this is what we have discussed yesterday, and the course features being like you need not to have any kind of prior knowledge. Even Python and all, as you have seen, we will be covering in detail. Okay, so we won't be skipping those classes or skipping the topics. We will be covering those in detail. And this is the same thing, like zero to advanced learning. We will be starting with Python, and we'll end up with the advanced generative AI, even those fine tuning of LLMs and the deployment of LLMs like that. So there we'll be closing, and then 3 months of in-depth training, as I have mentioned yesterday. And I'll provide the study materials as we have discussed, and I have shown you a sample of it, right? And interview questions will be provided, assignments and exercises. And for your simplification, I'll be I have lots of mind maps and simulations inside. Okay, even for large language models or fine tuning and convolution neural networks, whatever may be the topic. So there might be times where some concepts might look a little bit critical or complex. Of course, we will be discussing them thoroughly. However, you need to have to quickly understand what is going on actually. So we will have these simple animations, and of course I'll be noting everything down on the notepad, and will be explaining things along with the exercise and projects. Okay, so if we keep see such kind of things, it will be very easy for everyone to understand the concept. That is the main intention. So that's a thing. So to all those who have joined today only, so you can go through the video yesterday, so where I have shown you the detailed curriculum. And today is a session for introducing you to deep learning, so I'll have to concentrate on that more than what we discussed, right? So that is what we are going to start now. And as you have already gone through a definition of the deep learning, I would like to ask any of you to tell me the definition of deep learning. Okay, so so you would have seen this, right? Deep learning uses multi-layered neural networks that discover complex patterns automatically, right? So of course it might be you are not may not be aware of this neural networks, and you may not even heard about this neural networks at all. So I'll give you a very good understanding on that. Okay, so this is the first slide which we have discussed yesterday. This is a AI ecosystem, and on the right side you can see Geoffrey Everest Hinton. He is a godfather of artificial intelligence, and his primary contribution mostly on deep learning, because deep learning is kind of backbone to generative AI, right? So whatever the neural networks you use, the same kind of neural networks applications we are going to use in generative AI. Okay, so applications of deep learning is what we'll have to see today. So when I say deep learning, and I this particular field uses multi-layered neural networks, you may not know what is the beauty of deep learning, right? So if you look at these applications, so image recognition, so let me tell you this face recognition, where you unlock your smartphones, or even security surveillance, airport immigration time will be they'll be using some scans, right? And of course you might be using the Facebook, where automatically your system detects your friends faces, right? Social media tagging is what we call it. So face recognition and all is an application of deep learning. Okay, and we see this speech recognition or voice assistants and voice assistants like Siri, Alexa, Google assistants, so which can understand, transcribe, and respond to your natural speech. So those are all the applications of deep learning. And of course we have image recognition as well, so that we have seen here, right? uh, the x-rays and detecting the tumors in x-rays and MRIs. So it has become possible and become easy by using these deep learning techniques. Okay, and self-driving cars we have here, so which enables vehicles to detect pedestrians, traffic signs, and other vehicles, and safely navigate the roads. So these are all this comes under the autonomous vehicles, so which is also part of your deep learning. And of course this natural language processing, like, so you use Google Translate, right, for language translation from let's say Hindi to English or something like that. So those Google Translation, chatbot, sentiment analysis, or spam detection in emails, those are all your applications of this particular natural language processing, and it depends on deep learning neural networks only. And recommendation systems, of course there are many other applications like recommendation systems. So if you open Netflix and you see, right, whatever the movie you watched yesterday, same sort of movie the system will be recommending you. So those kind of suggestions on movies on Netflix, or products on Amazon, videos on YouTube, etc. So those recommendation systems can also be built using this deep learning. All right, and the medical diagnosis, fraud detection, gaming, and all. So those are all nothing but your applications of deep learning. I thought of writing all the applications in the notepad, however we do not have much time today to write those points, what are the applications in detail. Okay, that we'll cover up during our regular classes. Okay, today I have a limited time frame, right? So some of you have to go to office and all. So but I need to complete this session with a very good conclusion, so that is my aim for today, right? So that's the reason I'm little bit rushing over light things, and will concentrate on whatever the concept is all about. Okay, so so this is the thing. Way back in 1943, this is a brain inspired idea, right? So it is a very beginning. So when deep learning started is a question here. So when deep learning started, two scientists, so McCulloch and Pitts, so they proposed a simple mathematical model of a neuron, as you can see on the board, of a neuron. So they proposed this particular mathematical model. So their thought is like, can we make a machine to learn things exactly like a human brain does? Okay, so for example, if I am giving a speech to you during the class, it means lots of processing are happening inside my brain, right? So if I want to deliver the speech, lots of calculations or some kind of a processings are happening inside my brain, right? So they also thought the same way, like, can we make these processings or calculations in an artificial manner? Okay, so that is the question, can we make a machine to learn things exactly like a human brain does? So they thought like that. And then, so how our brain works, they wanted to create this artificial neural network. Okay, I mean, for now you can take it as a machine. Okay, so this was the idea which inspired people to unveil a concept called as deep learning. And now we can see the wonders deep learning is doing right today, right? And this is history of neural networks. Okay, of course I did not introduce you to neural networks yet, I know that, but you can see the history of deep learning here. Okay, so to just tell the historic moment, or the greatest one of the greatest achievements of deep learning, I could say about this particular event, so which happened in 2016, where AlphaGo is an artificial intelligence program, so developed by DeepMind. So it is a subsidiary of Google actually. So this event is historic because Go, there is a game called as Go, which looks very much similar to chess, and of course it will have lots of permutations and combinations to make a move. So like in chess we make several moves to check, right? So in the same way we have this game of Go as well, and it will have lots of permutations inside, more than the chess does. Okay, so in this particular game, so the alpha Go algorithm, okay, so it is able to defeat the world champion. Okay, so the thing here is that, I mean, the most important part over here is that AlphaGo did not memorize any moves. Okay, it learned how to play by practicing just like a human. Okay, so this is the beauty of a neural network, right? So just like humans do, our AlphaGo has also practiced, and practice in the sense it finds very good processing steps and calculation steps while it watches the game. Okay, and it defeated that world champion. Okay, so this is what the deep learning is all about. I mean, I'm just telling a one historic moment. You can now look at things, right? You can imagine how important are things, right? And then we are moving to this the definition of deep learning, what we have seen earlier. Deep learning is a subset of machine learning at artificial intelligence that uses multi-layered neural networks to model and understand complex patterns in large data sets. Okay, of course this might be a little bit confusing for you, but so deep learning is inspired by the structure and functioning of the human brain, right? So that's what I would like to say, and it involves networks with multiple layers. So let us come to this part. Okay, so on the left side you can see the human brain, right? I mean, human brain is made up of billions of neurons or nerve cells, right? Which are natural neural networks inside of our brain. We have billions of nerve cells or neurons, and I have taken a single neuron here. Okay, so this is a single neuron nerve cell, we can call it as. And if you see on the extreme left side, we find a part like dendrites, right? So dendrites are like inputs. So if somebody is pinching me now, I'll get some pain, right? So that pain signals will be sent to brain, and like this, right? So those pain signals are coming from the dendrites, and our there is a important part in the nerve cells itself. It is a cell body. Okay, this is called as a cell body, and it processes whatever the inputs we are getting. And finally we have the synaptic terminals, which are kind of outputs. So whatever the processing happened, so that particular outputs, so they'll be coming over here, and this nerve cell will be connected to some other nerve cell, right? So some other nerve cell. Okay, so where this information will be sent to some other nerve cell. Okay, so that nerve cell might be detecting where exactly that person pinched me. Okay, so in what location of my body that person would have pinched me. So this nerve cell will detect the pain signals, and the next one might be detecting where exactly this happened. So that's what a nerve cell will be doing inside our brain. And if you call this as a natural neural network, okay, and I have one more neural network here, where the input layer is here, hidden layer, this is the processing layer, and the output layer, which is just like synaptic terminals. So dendrites are nothing but your input layer, and cell body is nothing but your hidden layer, and the synaptic terminals are nothing but output layer. So here also some input layer is getting some inputs, and hidden layer is processing it, and whatever the processing happens, that calculations will be sent to your output. Okay, so if we call this as a natural neural network, we made this artificially. Okay, so our researchers have made in the same way like nerve cell is. So they created something like this. Of course, this is simple neural network, and they created artificially, and this particular neural network can be called as artificial neural network. Okay, so if you call this as a natural neural network, I mean the nerve cell, you should call it as a artificial neural network, right? So that's what artificial neural network means. And studying about these artificial neural networks, or in-depth study of artificial neural networks, right, is nothing but your deep learning. Okay, so now you understood a little bit of it, and You know how a neural network look like, artificial neural network? It looks something like this. Okay, so the input nodes, and there is a this a hidden node. So this input layer, hidden layer, and output layer, right? Here we can call it as input nodes, and this is your hidden node, and this is your output node. Okay, so I have taken a simple neural network. Okay, I have taken a simple neural network where I have two inputs, and there is only one this hidden node, and we have only one output. So this is a simple neural network that I have taken, and this can be called a single neural network. Okay, so I was telling you, right? So this is what I have taken, at least in a similar manner. So this is a simple neural network I have taken, and if you keep on adding the nodes, then it becomes a shallow neural network. Okay, and if you add a number of hidden layers in between this input layer and the output layer, this becomes your deep neural network. And the study of deep neural networks, as I said earlier, which is again artificial neural network, right? So the study of deep neural network is nothing but your deep learning. Hope you got it. So hope you do not have any doubts on this, right? So of course this might seem little bit complex. So this is not at all complex, but as I am going little bit faster, as I have time constraints to complete or to conclude this session well, so I'll have to little bit rush on things, but of course the concept remains the same. So there is nothing different. The study of this deep neural networks is nothing but your deep learning. All right, so now I have taken up one real time example. Okay, so some real time example. So let me start with a simple real life situation that all of us can relate to, right? So imagine you're on your way to office in the morning, right? And there is a road you cross every day, right? So now think about what you usually do before you cross the road. You don't just walk onto it without checking, right? Because some vehicles might be approaching in this way, and we should be cautious. Okay, so in this kind of situation, what you'll be doing? So you either watch whether any vehicles is approaching you or not. Am I right? Right, so that is one thing. And so these are the things, right? We'll get in mind. So those are nothing but your inputs. Okay, so is the road clear or not? That is one thing, because you'll have to cross the road, right? So this thing comes into your mind. So whether the road is clear or not, that is the first thing. And whether you are able to hear any cars, right? So some engine sound or some noise or some car honking sound and all, you will check these two things firstly. So based on the decision you take upon these inputs only, you will either make a decision to cross the road or not. Am I right or wrong? Right, so these are called as your inputs, and the importance you give to these inputs is nothing but your weights. Okay, so we have terms like weights. So these represent the importance your brain assigns to each input. Okay, hope you are getting this. Just have a look at for 20 seconds. This is a real life situation, right? Even after some 45 minutes we'll have to go to office, right? So this, while crossing the road, these are the things which comes into our mind. That is the reason I have taken this. And if you can understand this particular example, you will understand at least 30 to 40% of deep learning concept. I mean, what is happening inside, at least. Of course there is a lot of concept on deep learning, but you will understand what actually is happening inside a neural network. Okay, that is my intention. And I have taken a real time situation like this to make you understand better. All right, okay, hope you have gone through that. Now whatever the input nodes I have taken, okay, so usually the neural network will look something like this. Okay, so you'll have the inputs, and this is the hidden node. Okay, So this is a hidden node. To keep it simple, I can draw over here. Okay, don't get confused. This is very simple topic, and we are going to have some thorough understanding and deep understanding on these concepts. Okay, we'll spend some good amount of time over there. So these are your inputs, x1 and x2, am I right? And you have some hidden node here, and you have some output. Okay, so this output will be telling whether this person has to cross the road or not. Okay, so this is what this output will be telling at the end. And what are the inputs he's having? So is the road clear no or not? And the next one is, and can you hear any kind of cars? Okay, that is the second thing. So the neural network will pass this information like this. Okay, so hidden node is all about processing, right? So the processing will be happening inside. Okay, and x1 and x2 are your inputs, and w1 and w2 are nothing but your weights. Okay, what importance you are going to give to these particular inputs, that is nothing but your weights. Okay, hope you got it and you understood, right? Some kind of processing is happening inside, right? Some processing is happening inside this hidden node that we have discussed. Sorry, I should not have written. So this is a hidden node, and this is the output we have, right? So this output, so this should say cross the road or don't cross now. Don't cross. Some vehicle is approaching. Uh, so so your brain will be saying this kind of decision, don't cross the road now, something like that. So this is a simple neural network I have taken, and let us see. So this is the one I have taken, right? So this is a neural network I have taken up now. Okay, so and I'm adding some caution. So some caution, like I'm not giving more importance to that visibility and hearing only. Okay, I'm giving some caution to my human brain, that my brain is giving that caution, like, so be careful. So if you take a wrong decision, you will end up with an accident, so be careful. So that is the caution I'm adding to my processing, whatever I have here. Okay, so that's nothing but your b. Okay, so as I said, so some kind of processing is happening inside a hidden node. It is represented like sigma and f. Okay, so this sigma and f, and we have this output. All right, so for simplification, since this is a new class, I mean the first class to you, I need to write this particular neural network simply. So I divided your processing into two parts, like sigma and f. Okay, so what is this sigma and what is this f and all, we will discuss. So one thing I would like to say, this might be little bit what do we say, for you it is new, right? So you might feel these are all new things, and we are going little bit in a faster manner because of the time constraint I have for the demo, right? And if it is a regular class, I would have given a deep understanding on what this and all, but I would like to end up this session very well. That is the reason I have taken this particular example. And so these things might be little bit new for you, but if you understand this particular example, you will understand how a neural network will behave inside, and what kind of processing happens inside, and what is the beauty of this deep learning, and particularly the deep learning neural network. Okay, so if you can understand this particular example, so most of the concepts in deep learning are based on this kind of the flow itself. Okay, so that's the reason I'm taking up. Okay, so what I have done over here is that I have taken this particular example. So let's say it is around some 8 o'clock in the morning, and that person has this kind of inputs, right? So one, he finds road is not clear, which means some vehicle is approaching towards him. Okay, some vehicle is approaching towards him, which means the road is not clear. And there is one thing, so basically he is also hearing some kind of car horn sound. Okay, so in Indian roads, while you cross the road, what are the things you have? So you won't be looking only in this direction, you will be looking in the opposite direction as well, because we don't know from which side a vehicle can approach us. Okay, So we don't want that situation, a dangerous situation, right? So we'll be carefully looking on this side and on the opposite side whether any vehicles are coming or not. So so in this situation at 8 o'clock this person is going to office, and you know what he has done. He found that a road is not clear, and vehicle is approaching towards him, and some car horn sound was heard. So what he'll do, he will not cross the road. Am I right or wrong? He will not cross the road. That's why the output is 0. Okay. And at 8 2, so let's say some this is 8 2 a.m. Again after 2 minutes what he wants to do is that he wants to cross the road, right? He is going to office. Obviously he'll have to cross the road, and then he checks the road is not clear. Again some vehicle is coming towards him, and but there is no vehicle sound like engine sound or noise near him, which means, so since one of the input is not clear, since he found a vehicle approaching towards him, he will not cross the road. Am I right or wrong? This is very simple. We will not be crossing the road. And 8 3 a.m. also what he'll be doing is that, so he tries to cross the road once again, and this time no vehicle is approaching towards him. So that is a good sign, right? No vehicle is approaching towards him, but he heard some car honking sound on the opposite direction. Let's say some kind of car sound. Okay, so in this kind of situation also, these are all situations. So this is at 8 a.m. situation, this is 8 2, and this is 8 3 a.m. situation. So something like that. I'm just telling a real life example. All right. And 8 4 a.m. he is trying again to cross the road. And what happened was, so the road is clear. He did not find any vehicles, and also he did not hear any kind of sound. So eventually he will cross the road. Am I right or wrong? Because so it is safe to go. Simply it is very safe to go. That is the reason he will cross the road. Okay. And the thing is that, if this particular this is human intuition, right? This is how we take the decisions every day while crossing the road. And for example, we have a machine over here. Let's say a machine is crossing the road today, now instead of you, let's say. So what kind of calculations will happen inside is what we will have to know. Let's say this is a machine. Okay, instead of a robo I can simply write as a machine, right? So we need to make our machine also follow this kind of process, right? So do not cross the road, do not cross the road, and cross the road at when you find the road is clear, and you are not able to hear any car honking sound or engine sound or any noise, people shouting in front of you saying don't cross the roads. Those are all like sounds, right? So when you find those, you will be crossing the road. So we will have to make our machine to take a decision. All right, that is our main aim. So what I'm doing right now is that I'll take up this particular example, and let's do some calculations. Okay, so now is the time for calculations, and if you understand this calculation, so you can this is what a deep learning calculation is all about. Even I teach you some 30 hours or 20 hours or whatever maybe the deep learning concept. So almost all these 20 hours, internally we won't be doing these calculations as a generative AI engineer. So that is a thing I would like to say. If you are a generative engineer, you won't be taking a paper and pen and doing all the calculations. Okay, so don't keep that in mind. So whatever I'm telling you right now, it can be simply imported. Okay, simply import that particular library and do all these calculations. That's it. With a single line you can do all these calculations. Okay, but whatever I'm telling you right now will give you the beauty of deep learning. So that's the reason I have started. So firstly, let us assume some kind of values. Okay, so let me assume some values here. X1, as you know, let's say one example. X1 we have different values, right? X1 equal to 0 and X2 equal to 0. So this is the first one. X1 equal to 1, X2 equal to 0, and X1 equal to 0, X2 equal to 1, and X1 equal to 1, and x2 equal to 1. So I mean, what are all these? So this is the table I have taken up here, the table whatever I have taken over here. So 0 0 0 1 1 0 1 1, I have kept the same thing here. Okay, and so what is the processing happening inside that particular this thing? So hidden node. So that is the thing we'll have to see, right? And you can see some sigma is happening, but before that let me assume w1. Okay, so w1 I am giving importance as 1 and w2 importance as 1. So I am giving almost 100% importance to what I see, and almost importance 100% importance to what I hear. Okay, that is nothing but your weight. Am I right or wrong? So w1 and w2, right? And what I am doing next is I am also assuming some bias value minus 1.5. Okay, let's take these assumed values. These are all assumed values. Assumed values. Okay, you got this right. These are all assumed values, and deep learning is very easy. Please believe me. At least I'll make it super easy. All right. So w1 equal to 1, w2 equal to 1, b equal to minus 1.5. Now what I'll have to do is the first step to calculate the output is to calculate the output. First we will have to calculate this step, the weighted sum. So the first one is calculate the weighted sum, and the next step is that what is this function? So apply some function on it. Apply some function. So these are the steps we have. Am I right or wrong? These are the two steps for me or for my machine to decide whether it has to cross the road or not. Right? You got it right. So this is the output.
Yes.
We have to make our machine whether to cross the road or not, and to reach this point we'll have to do certain calculations, which are nothing but your weighted sum and some kind of application of function. So that's what I have written over here, and let us do some calculations. Okay, so just don't get scared of these calculations. These are all simple firstly, but also these calculations will be done with a single importing of some library, some Python library you can import, and all these calculations will happen on its own. Okay, you need not to do that. So what I'm doing right now is I'm calculating the sigma first. Sigma, so I'm representing that as some z. Okay, for simplification I'm representing that as z. Okay, so the formula for this z is w into x plus b. Okay, so whatever the weights you have, that you are multiplying with your inputs, and you are just summing up with some bias. Okay, so bias is nothing but your caution. Okay, be carefulness we can take it as caution, something like that. Okay, now let me calculate that z equal to we have two inputs and two weights, right? So it becomes w1 x1 plus w2 x2 plus b. Okay, just the summation sigma is nothing but this, right? So what I'm doing is that at 8 o'clock this person is crossing the road and the values are 0 0, right? X1 equal to 0 and x2 equal to 0, the same thing I have written over here, so don't get confused. So z equal to w1 into x1. What is w1? 1 into 0 becomes 0, so 1
Zero.
into 0 plus 1 into 0 minus 1.5. Am I right? So z equal to
Yes.
minus 1.5, right? And in the same manner, if you do the next calculations, right? So this is the first one. So what I'm doing next is that second one. So I'll take up some other situation like this at 8 2 a.m. X1 equal to 1 and x2 equal to 0. Okay, this is the thing I'm taking up now. Z equal to 1 into 1 minus 1 into 0, I mean plus 1 into 0 minus 1.5, which becomes minus 0.5. Okay, the second one is also there, and the third one being x1 equal to 0, x2 equal to 1. So here it becomes 0 into 1 plus 1 into 1 minus 1.5, which again becomes minus 0.5, right? And fourth one here being z equal to the same thing, 1 and 1. Okay, 1 and 1 this time. So at 5:85 a.m. So these are the values we have. So that I am writing over here. That's it. Okay, don't get confused on these things. Okay, 1 into 1 plus 1 into 1 minus 1.5, which becomes zero point 0.5.
Point
Okay,
five.
so yeah, so all these are some negative values and you got one positive value here, right? So the first step is done. So simple weighted sum is done, and next step is that we'll have to apply some kind of function on this, function on whatever the weighted sum we get. Okay, for that I am taking up one kind of step function, or the function I mean, let's take that function here. So our aim is to calculate that output. Okay, our machine, whatever we have, its aim is to calculate the output, right? So what we'll be doing is that, so if z value, if it is less than 0, so your output equal to 0, y equal to 0 means, z equal to 0 means, so whatever the values you got, z is less than 0 means, so what does it mean? Y value is 0. Okay, and if z value is greater than or equal to 0 here, like whatever the function I have taken, so this is a function, so this function is called as step function. Okay, step function. Okay, so z is greater than or equal to 0. So in these scenarios, y equal to 1. So this is a mathematical formula. Okay, I'm not at all deriving anything. Okay, so this is the step function that we would have used during our btech time. All right, so in this scenario, minus 1.5, if you apply that step function, what is the value you will be getting? So for z less than equal to 0 means this is minus 1.5, right? So it is less than 0. So your output y equal to 0. Am I right?
Yes.
And here also z equal to minus 0.5. So z is less than 0. So your output is again 0. So do not cross the road. Do not cross the road is a output we have got now. And this is also minus 0.5. So here also your output will be 0. Do not cross the road. And here you got positive sign. So if z is greater than or equal to 0, which means 0 and some positive value, your output
Safe to
is
cross.
1. Safe to cross the road. Safe to cross the road, right? So we have made our machine to safely cross the road. Okay, so these are the outputs we got. Am I right or wrong? Am I right or
Yep.
wrong?
Yep.
So this
Yes,
is
Naveen,
very
it is
simple.
clear. One clarification,
Yeah.
but our mission
Mm-hmm.
output is based on whatever the what is that you're giving 1.5, right?
Yes,
Bias or
absolutely, absolutely, absolutely. I'll be telling that. Okay.
okay,
So
that is
that is,
determining. Okay,
yes, yes, yes,
okay,
absolutely.
okay.
Yeah. So let's say we have these four examples only. We have these four examples only, and our model is able to, take a decision based on these four scenarios. Okay, nice. That is well and good. But what if you have some millions of scenarios like this? Okay. So, so for example, I am putting this over here. Okay, this is very simple. See, so it's not like 0 and 1, right? You might even have some 0.9 and 0.9 like that. So car is far away. So it is little bit far away. So this is far away, right? Zero point 0.9, and zero point 0.9 is that some slight car sound is heard. So usually we'll take up a decision, right? We can safely cross the road. Usually this is a human intuition, right? You can take this as a example that we are doing every day. Like some zero point 0.7 is that car is little bit far away, which is zero point 0.7, and x2 is zero point 0.6, which means little loud sound. Okay, and 1. So road not clear, car horn heard. Like this we have some 14 examples, but in real time, while you cross the road and all, during you go to office, you might even have some 14 million scenarios. Am I right or wrong? So you might be having some 14 million scenarios as well, right? So where x1 equal to, so car is very far away. Okay, but even some kind of sound is heard. So basically what we'll be doing, so we will not be crossing the road, right? It's all about these scenarios, they go in our mind every day, whether to cross the road or not. Am I right or wrong? Okay, so what I'm doing right now is, if I plot, what I'm doing right now is, so what I meant is that my model should not calculate every time. Okay, so what it have to do is that it should plot a graph, I mean inside, so that it should divide do not cross the road and cross the road. Okay, so these kind of situations. So for example, let's say you have this, right, 0 and 0, which means 0 and 0 comes over here. Am I right or wrong? This is a graph, x-axis and y-axis. So this is 0 and 0, and 1 0, which means here, and 0 1, which means here, and 1 1 will be here. Am I right or wrong? If I plot it on the graph, okay, if you're not able to see it clearly, okay, so 1 and 1, so this is nothing but your 1 comma 0, this is 0 comma 0, and this is 0 comma 1. So these are the points, right? These are nothing but your inputs, and if you plot them on the graph, this is how it comes, right? Okay, and so your machine, if it draws a simple line like this, okay, and if it plots a point, so it is able to divide whatever the points behind this line. So they might be do not cross the road, and whatever the points above this line maybe cross the road, right? If we draw a line like this, we are able to, we are able to distinguish whatever the points you that might fall in this region, whatever may be the points. Okay, so let's say take this as point 0.9 comma, so some point 0.8 something like that, point 0.1 something like that. Okay, so these are all just examples. Okay, so where a person will crossing the road, so if you write a draw a diagram, I mean draw a line, and you can differentiate whether to cross the road or not. Okay, so that particular line becomes your decision boundary. Okay, whatever the points you find here, you cross the road, and whatever the points you find here, you do not cross the road. So our machine should understand like this. Okay, in this manner, even if you have some 14 million scenarios like this, your machine simply plot the points on the graph, I mean internally I mean. So and whatever the points fall above this, you just cross the road, and below this you do not cross the road. Okay, so this way our machine will think. Okay, okay, you got it right, you got the example right. And there are some gaps, I know that, I know there are some gaps in your understanding. The first question which was asked is that, just because I have assumed these values, just because I have assumed these values, I got these values, right? I got the output or weighted sum like that. Okay, what I have done is that I have assumed the correct and exact weights and biases, weights and bias. Okay, but this is something you will have to understand. So I have assumed this w1 equal to 1, w2 equal to 1, and b equal to minus 1.5. That is the reason we are getting the exact output. If I have assumed this some random values like 0.6, 0.7 something like that, you wouldn't be getting that particular scenario, right? Like y equal to 0 or 1. Am I right or wrong? So the model training, whatever may be the model training, like generative AI model or deep learning or whatever may be the model it is. So what it will be doing is that internally it will assume some random weights and biases, some wrong ones. Assume some wrong and random. I'll write it over here. Assume some random and wrong weights and bias. Okay, so at first it will be doing this, and it will calculate the loss. Okay, loss and all, and finally finally it will get the correct weights and bias. Okay, So this is nothing but your uh, how a model training will look like. So whatever the values I have assumed here, so these might be wrong, or in this particular scenario I know these should be the values and I assigned correctly. Being a trainer and all, I know these are the correct values, I have assumed very correctly. But in a model, what it will do is that assuming some random and wrong weights at the starting, and then finally it will correct those weights and biases, and finally they'll end up over here. Okay, so this is nothing but your model training. Okay, whatever may be the generative AI or deep learning model you might be having, so this is how a model training will happen inside some random weights and biases, and it will get the correct weights and bias. Okay, so you would have seen, right? So one thing I would like to say, parameters of LLM and all. So you would have seen, right, the generative GPT 3.5 is trained on some 3.5 billion parameters and all. Did you see that generative AI model? So the chat GPT you are looking at, so we'll see, right, in the news, GPT-3 is trained on 175 billion parameters and GPT-4 on 1.76 trillion parameters, like that. So these parameters are nothing but your weights and biases. Okay, as simple as that. The correct weights and biases are nothing but your parameters. Okay, so whatever may be the situation your model get, so it will be assuming some kind of random and wrong weights and biases in the starting, and it will calculate the loss in between, and finally it will get the correct weights and bias. Okay, so this is nothing but your model training. Whatever may be the model, it is generative AI model, deep learning model, or whatever, this is how the model internally will do. And firstly I would like to say that all these calculations you won't be doing as being a generative AI engineer. Okay, that thing I would like to tell you, and I would like to take out of your mind. Okay, I'm requesting that, because all these calculations you can simply import one library, and that library will take up and do all these calculations internally within seconds. Okay, that you won't be doing at all. So you'll just have to write a single line of this thing: import TensorFlow. Okay, so if you write this particular line, so your model, it eventually do all the calculations. Okay, I mean, I'm just telling this simply. So this is nothing but your model training, and this is how it looks. And thanks for asking that beautiful question. So whatever the weights and biases and I have chosen, just because of that I'm getting these values, right? Yeah, that is absolutely right. But in real time we will not assume any weights. Okay, the model itself, it will assume some kind of random weights and biases, like something like the w1 equal to zero point 0.6 or zero point 0.3 or zero point 0.4 or minus zero point 0.4, something like that it will take up, and finally it will end up getting the correct weights and biases. Okay, some kind of calculations will happen in between, and we'll finally come up with this. Okay, so you may not understand the beauty of this calculation, but while we go through the deep learning concepts, okay, so this is the calculation we'll have. Okay, so only on the first class I'll be teaching this, and next, some good amount of knowledge behind this and all. Okay, so this is how the model training will look like. And the deep learning and all, it is very easy. Okay, not only deep learning, the generative AI as well, it is very very easy to learn. Okay, the thing is you have to get the correct flow. How should we learn this particular concept and all? You should get that correct flow, and eventually you can learn very simply. Okay, so that's what we have seen now, and we made our model to cross the road, right? At last we got that output equal to 1, right? So two things you would have got in mind: one is weights and biases, or not. We won't be assuming the correct values, because we do not know at all. Who am I to assume these values? W1 equal to 1 and W2 equal to 1 and bias equal to minus 1.5. I do not know at all, but for simplification I have taken these values. Okay, but in real time they will be initialized randomly, and finally end up with some good correct weights and biases. That's what I would like to say. And if you have understood this particular problem, we have you already completed 30% of deep learning concept. Okay, so 30% of deep learning concept is completed by this first session itself. Of course, there might be gaps in your understanding. I know, and I can understand that, but all this will be sorted, and in a cleaner manner we'll go through by the end of the session. I usually tell my audience that once you complete your deep learning, you immediately apply for some deep learning engineer post or something, whatever you find in job portal. Okay, so that's what I say. And of course, this is how my teaching look like. I know that I have taken some complex problem in the starting the first session itself, so this might scare you. Of course, I know that, but this is the only calculation we have in deep learning. Okay, so this is the only calculation we have in deep learning, and if you can understand that, so most of the part of deep learning is completed. Okay, that you keep in mind. And see, and not many times we can simply make a line and take a decision, right? Sometimes these lines may be curved as well. Okay, so those kind of situations we can't do anything, right? So this is the thing I have shown you just now. So this class 1 is nothing but y equal to 1. Okay, so these kind of scenarios we can simply draw a line and can tell whether cross the road or don't cross the road, spam email, non-spam email, positive value, negative value, approve the loan, reject the loan, buy the product or sell the product. So when you have these kind of scenarios, you can simply draw a line in between, and a model will be easily telling that. Okay, so that's all about. Okay, so if you have understood this, we have completed this deep learning concept in the first class itself. Okay, of course there are many internal things which we have to discuss, that I know. And we'll be covering deep learning for at least some at least around 10 hours, okay, in our daily classes. And by the end of the session, I'm pretty sure, and I can give you that assurance that you will be ready to become a deep learning engineer immediately. So yeah, so this is about today's session. Hope you liked it, and that is for first thing I would like to say. Hope you liked it. And if you find this complex, see, I'll have to rush up, right? So we have a limited amount of time, so I can't slowly write things. Okay, we have limited amount of time, and I'll have to complete this session um, as short as possible. So I'll have to rush up some things. Please don't mind on that. Okay, yeah, thank you so much. And I would like to say one thing. So if you have your colleagues or someone, please they might not be knowing that a new batch is starting, so you may send this particular this program details and all. So let the management handle that. So yeah, thank you so much. And if you have any kind of questions, I know there might be some questions, we'll discuss that in a regular classes. And tomorrow we'll see the NLP part. I mean, I'll check with the management how long I can take tomorrow's class. Okay, so NLP part, and you'll get some very good understanding on NLP as well. All right.
So we will have classes during the weekends also,
Yeah.
right?
No, we won't be
Mm.
having any classes during the weekends. Okay,
Mm-hmm.
we'll have some Monday to Friday 7:30 a.m. Okay.
7:30 a.m. to 8:30 a.m.
Yes, correct. Yes, correct.
Okay. Okay. So it is 20. So it is 3 months. So it is like 60 hours, correct?
It's not like that. It may even extend to some 70 or 80 hours. It depends, depends on the questions, right? As a trainer, I need to clarify all your questions. So sometimes that sessions may extend a little bit. So it is not a fixed thing, but it will be more than 60 hours for sure. Because if you have seen mine, the classes and all, right?
Yeah, in
So
the
you will have,
previous session, previous batches, like how
yeah,
many,
the previous batches, it was more than some 70 to 75 hours.
or the previous batch completed already?
No, previous batch is going on. It is night time, some 9:30 p.m. IST. So it is still going on, and today is a new batch which will be 7:30 a.m.
Oh, okay. So night also you have a batch for this session, for this training?
Yes, 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 we have, but we are not starting it. It started in May, actually. It started in May and it is going on May end actually. May end it is started and it is going on.
Oh, okay, okay. So how many participants you had there, Naveen? Just for my
I
because
cannot
you.
say that here,
Oh,
but I would
okay.
like to say
No,
that
no.
I
The
have
reason I was asking is when we have more participants, right?
Mhm.
So the type of questions and more interactivity, is that why it got extended? Or I see that
Yeah,
we have nearly 8 participants here. So
yeah,
that
yeah.
means we might also
I
have a
would
good.
say it is more than whatever the participants here. It is double actually, a little bit more than the double.
Mhm. Oh, okay, okay,
Okay. So this is a rough thing I am saying, but I should not say. But I have a good
okay,
audience in the previous batch, and our interactions were, you will come to understand once you go into this deep learning concept, or whatever
hmm
the entire training. I mean, all right.
okay,
Yeah. So if I have, you might be having some questions and all, but we will see them in our regular classes. So I didn't mean to scare you, but this is the beauty of deep learning. Wherever you learn the deep learning, you might not be starting at this point, but this should be the starting point. All right. So I would like to conclude this session with some output, right? That's the reason I have taken that problem and told you, though it is extended some 15 minutes, which is against the management rules and all, right?
yeah, sure, sure.
Yeah. So if I have confused you, yes, I'll have to rush up on some things, and of course, due to time constraint and all, I have told you many times. So don't get confused on that. We'll have a slow manner the classes and all. Okay, so that is the assurance that I can give you from my side. And I would like to say that so the Python classes and machine learning, it will be taken up by one more trainer. He is currently working as a AI product manager. Okay, so he's a AI product manager in Gartner. So he is also having some 9 to 10 years of experience. So he'll be taking up this Python, math and basics of machine learning. So the complete generative AI part is going to be looked after myself. So from deep learning and all, you will have
Oh, okay. So how many sessions will be through that trainer?
he'll have Python, math, and machine learning essentials.
Or 3 modules will be covered
Yeah.
by the
Yes, yes.
other
These are all
trainer?
these are all kind of foundation things, right? So the foundations and all will be
Mhm.
clarified by the trainer itself, and the more core part, which is the important one, the generative AI. So generative AI usually starts from deep learning, right? So here we'll
Mhm.
have some 6 to 7 modules, right? So 6 to 7 modules. I kept only 4 here, but you will have 6 to 7 modules. I'll be taking up them. Like if you want me to show that here, I can show that simply.
And Naveen, from
Yeah.
Monday onwards, Python will start.
I'll have to get confirmation on this on the manage from the management side,
Oh, okay.
right? Yeah.
Oh,
So
here you have not 10 modules here
yeah, the
in the
first two
previous batch.
modules, yes, yes, the first
Uh-huh.
two modules will be taken care by that person, that trainer, and the rest all will be taken up by myself.
Oh, okay. But in the other present PPT, we had only 7 modules, right? So in this batch, are we combining some of the modules or are we
Yeah, the
skipping which
PPT
are
and
not
all.
relevant?
No, no, no. The PPT and all, you please ignore that, because if you look at the all those things, we'll have lots of concepts. I just segregated them. Okay, so you,
Okay,
you
okay.
please don't look at that. I would
But
have
we'll
mentioned.
have all the same exact modules in this
Yeah,
batch
even
also, right?
even we are trying to add some more topics in machine learning and some other. Earlier in the current batch and all, we do not have that extensive coverage on machine learning, but we see the recent interviews people are asking. So there are some topics which are added for this particular batch. Okay,
Mm-hmm.
yeah, that's the thing.
Okay.
Is there any application oriented scenarios will be covered?
Yes,
Uh,
yes, obviously, obviously.
so because I mean, when it goes to the interviews, it's all project
Yes,
level
yes,
rather
yes.
than the theoretical, right?
Yes, yes. Do you feel that I'm explaining theoretically?
No, no, I mean, it's a first class. I mean, I'm saying,
Yes, correct. Yes, yes, obviously. So, um, yes, I'm telling, right? So, if let's say this is for 75 hours, the total one, on the
mm,
76th day, you can apply for the interviews. Okay. So, when
mm,
I give that confirmation or assurance from my side, which means you'll have to have a good knowledge on practical exposure as well. So, without that,
right.
we cannot attend the interview. So, because that is important, right? So yeah, the practicals and all will be thorough, so you need not to worry about it. We have given good weightage to practicals more than the theory part. Yeah, so if you have any further questions, please try to ask. If not, we can wind up the session. It's already 8:48. So
Yeah. Thanks, Naveen.
yeah,
Yeah,
and
yeah.
if you need any kind of more information on the batch details and all, I can share that brochure to you. Or yesterday I have shown you in the video, right? So you can go through that video where you can see that brochure and the topics we are going to cover. But that is also in a simple manner. Okay, I have told you that, right? So deep learning, you might see only 6 points in the brochure, but when coming to classes, we'll have to cover everything from zero level, right? So we'll have to keep that. So so I did not keep a lot of things in the brochure. So that's what
Mhm.
I mean. All right, hope you got some. So it depends on the management when the regular classes are going to start. I mean, probably from Monday you might see the classes getting started. um, yeah, you will get that kind of confirmation from the institute itself.
Yeah, yeah, thanks, Naveen. Yeah, I'm seeing the whatever in the website, right? Like how many modules? I don't know. It says module 11, capstone project, project 1, project 2, module 12, interview preparation. So all those are part of this, right? Even though it's not
Yes, 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 yes,
correctly segregated.
yes,
This
yes.
is the link I was mentioning about. I don't have this option to chat, right?
Okay, okay. Yeah, yeah, yeah. Yes, yes.
Okay, okay,
Yeah,
yeah. This is the
you.
link. Let me put it in private chat. Yeah, this is the link I was saying, which it is put in the website, right?
Yeah, the same thing. The same thing
Oh, okay.
here. Yes, there is no difference at all. The same things.
So Naveen, are you on LinkedIn?
Sorry, sorry. Your voice is breaking up.
Uh, Naveen, are you on LinkedIn?
Yes, I'm in LinkedIn, but as per I'm currently working in banking domain project, so I should not reveal those kind of details. Okay, so I
Sure,
have
sure.
all,
No.
yeah, I'm
Yeah.
I'm working for some company, so which is a very good MNC, and it has some strict rules over there. So that's the thing.
Um, yeah, hi Naveen.
Hello,
Uh,
hi.
yeah, yeah, I'm from Java background. How it's useful for me and for this application development and all, is there you can use any tools kind of things of in Python by using?
No, I'm not able to understand. Your voice is very low, and
Hello,
yes, yes, yes. Please repeat.
this application development, right?
Yes,
After we complete that by using this one.
yes, yes.
So for that, we use any some IDs or any tools by using that one we build, or how we after we learn all the things in real time.
IDs and tools you're asking, right? Some
Yes, yes.
tools I understood. So yeah, as I was telling you yesterday, so there is no special infrastructure or special laptop you require for practicing the generative AI modules. Okay, whatever the concept may be. So you can go for Google Colab, where you can write the code simply here. Okay, and you can execute it. I mean, if for your particular model, if that particular cpu, whatever the cpu you're having in your laptop, it is not sufficient, then you will have to purchase this Google Colab. And most of the times it is not at all required. Okay, it is not at all required. You can you can simply train your model here itself. Okay, or for fine tuning and all, you might require what do we call, some good GPUs. Okay, in those times you can purchase this Google Colab. Okay, but most of the things will be covered in the class itself, and I'll be training. This is my Colab Pro account. Okay, so fine tuning I'll be doing that, but 90% of all your models or your code can be executed in Colab free account. Okay, so there will be some 10% where you will have to take some pro account, or you will be having the Kaggle website, or some other websites where they provide GPUs for free of cost for a month, or for some number of units. There also you could train your models. Okay, so what I'm saying here in short is that 90% of whatever the code we are going to write, you need not to have a special laptop. Okay, so that is one thing. And this is about your local environment. So this is a local environment, but you can also do the same using the cloud as well. So there also the cloud GPUs and all, $0.35 per hour, right? $0.35 is very minimal, right? So there, while you take up some account, you can do the fine tuning, but there also you need not to purchase anything. So they'll give some GPUs for free of cost, or normal ones you can try it, right? They
Okay. And yeah, one more thing. Usually our applications by using CI/CD pipelines, by using we are deploying in cloud servers. So in the similar way, after deploying these applications, also usually do the same process, or
So CI/CD pipelines is what you're saying, right?
yeah, I
Yes, in
mean
the same way. In the same way.
in the same way.
Yeah.
Okay. For deployment is by using this GenAI, and after complete this development part, we go for operations part. Usually we go for some DevOps tool kind of thing, and by using cloud.
Okay.
What I'm understanding is correct.
Mm-hmm. No, actually, your voice is a little
No, no.
lower.
So yeah, hello. So is it audible, right?
Yeah.
So what I'm asking is,
Mm-hmm.
so after you're developing all the applications,
Yes.
whatever in by using GenAI,
Mm-hmm.
so for in live production, in deployment, and that
Yes.
process, I'm in by using.
Yeah. Yeah, we'll be covering that part. Like I have kept that in our brochure as well, right? Deployment of application using the cloud, right? That part we'll be covering up.
Okay,
The same
okay,
way,
that tools also come in the
the
part.
same way you will be doing in real time. So we'll
Yes.
be having that session as well, and it's part of our training.
Okay, Navi. Yeah.
So if you have any further questions, we can discuss, or we can wind up the session, right?
Yeah, sure, Naveen.
Yeah. Thank you so much. Have a great day.
Thank you. Thank you all.
Thank you. Bye bye.
Bye.